Welcome guys, this is Tutorial Center. If you haven't yet, subscribe to the channel, like and share the video. Today we are going to be looking at the question in polynomials. Read g of x is equal to x plus 1, x plus 3, q of x plus px plus q is a polynomial of degree 3. Given that g of x leaves remainders 8 and negative 24 when divided by x plus 1 and x plus 3 respectively, find the remainder when g of x is divided by x plus 1. Okay, at this juncture, I'll recommend that you stop the video and take a look of the question, that you get back to what we have done. Okay, if x plus 1 leaves a remainder of 8 and x plus 3 leaves a remainder of negative 24, it means that g of negative 1 is going to be equal to 8. So g of negative 1 is going to be equal to 8, and likewise g of negative 3 is going to be equal to negative 24. G of negative 1 just means we substitute the variable negative 1 anywhere we find x, which is here, even here also, and we see how that goes with simplification. Okay, substituting negative 1 here, and here, all of this becomes 0, because negative 1 plus 1 is 0. So all of this multiplies to 0 and cancels out, while we are left with an equation only in terms of p and q, which is this. Okay, this is for g of negative 1 equals 8. You can understand with the colors. Now this will simplify to q minus p is equal to 8, which we will call our equation 1. Okay, let's do the same thing. We substitute negative 3 in g of x and see how that leaves us. Remember, this is how we divide a polynomial. That is why they said find the remainder when the polynomial is divided by x plus 1 and x plus 3. So you divide the polynomial by substituting in a certain factor in this case, which is negative 1, and equating it to the remainder. In most cases, the factor divides a polynomial and leaves a remainder of 0, but in other cases like such, the remainder is not 0. In this case, the remainder is 8 when it's divided by x plus 1, and negative 24 when it's divided by x plus 3. Okay, let's move on. So when we substitute negative 3 in all the places where we find x, here and here, we get all of this to become 0. All this cancels out to 0, while we are left with an equation only in terms of p and q. So this is looking pretty good for us. We can see that we are on the right track. Okay, finally, the equation in terms of p and q that we get from here is q minus 3p is equal to negative 24. So this is our equation 2. Now you might want to know simultaneous equations at this point, because we are just going to apply it in this video. So solving equations 1 and 2 simultaneously, obtain values of p and q. We get p is equal to 16 and q is equal to 24. Quite a coincidence, right? Q is 24 while the remainder is negative 24. Okay, so we proceed. Now what we said was, when we divide a polynomial simply by just substituting that a certain number and equating the polynomial to its remainder when it is divided by that number. We have done that for g of negative 1, and we have done that for g of negative 3. And when we did that for g of negative 1, what remained was px plus q. When we did the same for negative 24 for negative 3, what we still had was px plus q. What that means is that the remainder is of the form px plus q, and since the remainder is of the form px plus q, it means that the remainder which we are looking for is just 16x plus 24, where p 16 and cure is 24. Okay guys, that will be all for now. If you want, if you wish for the B part of the question, leave a comment in the comment section, and we'll see in the next video.